In Chapter 11, we began a topic covering sequences and series. And today, we're going to talk about arithmetic sequences. You notice the title, it looks like we're using the word arithmetic. Arithmetic is a noun, but when it becomes it's spelled the same way, but when the word becomes an adjective describing the type of sequences, what kind of sequences, then it is pronounced arithmetic. And basically, sequences are numbers that are, you can think of them as a list of numbers, but they follow a particular pattern. And when we specify an arithmetic sequence, that pattern is this. We should be adding the same number each time to get to the next term. Each of these numbers in the sequence is called a term. So if it's true that we are adding the same number each time to get to the next term in the sequence, then it's described as an arithmetic sequence. Alright, so very simply in 2 through 10 even, it's really a two-part answer. The first thing they want to know is the sequence that you're given arithmetic? Well, in letter A, it looks like we are adding 9 each time. And if it gets difficult, letter A is probably pretty obvious to you, but you can always do this little subtraction. Just group these terms together, just make a pair. I've grouped the first two together, and I'm going to take the second term in this group and subtract the one before it, and my result is 9. Okay, and I'm just gonna, just to see if this pattern holds, I'm going to keep doing this. So here's the next two paired up, and I'm going to do the same thing. The 9 in this pair, and then subtract the 1 in front of it, the 0. I get 9. Okay. And I'll just color code these so you can kind of get an idea. Let's move to another pair, and let's do the same thing. 18, take the second number in the pair and subtract the one before it. And you can tell that when I do that, each time I get the same result. So this is proof that this truly is an arithmetic sequence. And identify the common difference. Well, that's what we did in our proof. The common difference, that result that I get every time I do this little subtraction with the pairs, is my common difference. And so in this case, that would be 9. Okay, well in letter B, some of these might be kind of obvious to you, but if you took these numbers and subtracted 0.01 minus 0.1. Alright, if we were to do that, and I'll just grab my calculator. You may have your calculator handy, but let's just do that little subtraction so you can see it. 0.01 minus 0.1. Our result is negative 0.09. Okay, now let's try that coupling up the next pair, and you can probably already see it, but let's just do a little proof. If you take the second term in the pair and subtract the one before it, what's the result? Alright, so we'll just grab our calculator so we can have something to look at. 0.001 minus 0.01. Well, that's something completely different. That's negative 0.0009. So since I did not get the same result when I did my little subtraction of the pairs, then this is not an arithmetic sequence. And so therefore I don't have a common difference. There is no difference in common, and we just proved that with just using the first couple of pairs. Alright, let's do it again. Letter C, I'm going to put these first two terms together, and I'm going to do 10 minus 7, and I get 3. Okay, let's pair up 10 and 13. 13 minus 10. You always subtract the second in the pair minus the one in front of it. Alright, so far so good. And I don't trust these problems, so I like to just go ahead. They might trick me with this last pair, so I'm just going to go ahead and test it. Here I'm going to do 16 minus 13, and I also get 3. So I get the same result, and I can assume by these ellipses on the end, these 3 dots, that it continues along in the same pattern. So yes, this is an arithmetic sequence, and the common difference is 3. Alright, got a couple more here. Let's try testing letter D. Remember, we pair them up, and we can do the second minus the one in front of it, and that result is -4. Okay, let's do these paired up together. Second one, 20 minus 24 is -4. Alright, let's try one more pair just so we don't get tricked. 16 minus 20, also -4. So we've proven that this is an arithmetic sequence, and the common difference in this case is a negative number, and it should be pretty obvious because our sequence of numbers is decreasing as we go to the right. Alright, well, let's try this one. Put these first two together and subtract. We'll do 1/4 minus 1/2. Well, we know that 1/2 is the same thing as 2/4. Remember, we can't actually subtract these unless they have a common denominator. So 1/4 minus 2/4 is -1/4. Okay, so let's move on and we'll try this. Subtract the second number or term in the pair. Do the second one minus the one in front of it, so in this case that would be 1/4. Well, again, changing to a common denominator, this would be 2/8. So 1/8 minus 2/8 is -1/8. Well, there's no reason to go any further because I did not get the same result when I did my little subtraction proof. So my answer here is no, this is not an arithmetic sequence, and so therefore I don't have to worry about a common difference because obviously there isn't a common difference. Alright, so you got, I think, 5 of those to work on, to practice. This slide is really just more or less for information to kind of set up my next slide. Just take a look at this. You don't have to write all of this in your notes, but I do hope that you'll pick up on a few, vocabulary words. First of all, we have this arithmetic sequence. We know this because it looks like we're adding 4 to get from one term to the next. And I've already been using this word term to indicate the actual numbers in the sequence. So these individually would be terms of the sequence. Alright, and we identify terms by using this little indication here, notation A sub n. Don't let that throw you. For some people that's really confusing. It's just a notation. For example, this, when I change n to an actual number, it stands for the third term in the sequence, and applying it to this particular sequence, that would be 11. Alright, so this would be term A sub 1, A sub 2, and so forth. And I gave you another example. A sub 4 would just mean the fourth term in the sequence, and that, in this case, it would be 15. Well, I said all that because this, again, this little notation tends to give people fits. So let's just take, for example, we've got this sequence, and I don't really know what this term is or this one. I just know right here I've got this term identified as A sub n. Well, let's just use some actual numbers for example. Let's just say I know that this is the fifth term. Doesn't really matter what the number is, but here I've turned n into an actual number, so that it means the fifth term? Well, obviously the term over here to the left would be the fourth term, and to the right would be the sixth term. Well, mathematically, how did I change this n subscript from 5 to 4? Well, obviously I subtracted. So if I'm showing this using variables only, the term to the left of a sub n would be a sub n minus 1. Okay? And then the term to the right, as you can tell mathematically, I'm just adding 1 to this subscript 5. The term to the right of a sub n would be a sub n plus 1. Alright, so again, just getting you used to the notation here, because this little subscript, it's n, it just stands for what position in the list is a particular term. And if you're looking at it in variable form, to the left you would subtract 1, just like I did here. To the right you would add 1. Okay, and that kind of helps us set up using a couple of formulas. And you're going to do this on 12 through 20 even. Here's a good example of one of these problems. You're asked to find the 25th term of this sequence, and they've given us the first 4 terms. We're supposed to find the 25th. Now let me just give you a word of caution. On the test and sometimes on quizzes, I ask this question, and sometimes I'll say, give me the 98th term. And you probably guessed it, in order to avoid learning formulas, I actually will have people list out, they'll just keep running this out until they actually find listing 98 numbers. And I'm not going to be able to give you credit for that. I want you to, especially in this exercise, I want you to drill using this explicit formula. And I want to explain why the explicit formula is much better to use in this case than this recursive formula. Okay, so make sure you practice the formula, because you're going to have to show that you know how to use it. Alright, so let's get back to this. Find the 25th term of this particular sequence. Well, I'm showing you 2 different arithmetic sequence formulas. But the one we're actually going to use in this case is known as the explicit formula. I'm showing you this because it does come up. It'll come up probably again in your pre-calculus course. I've seen it on some ACT practice problems. Let me first of all explain the explicit formula, and you can kind of think of the word direct when you're dealing with the explicit formula. It's kind of like a straight shot directly to a particular number in a sequence. Let me explain. Alright, so remember what a sub n refers to? That just means we're looking for a particular term in this sequence, and since it tells us to find the 25th term, I'm going to let this become a sub 25. Alright, well, you probably know now that a sub 1 refers to the very first term in the sequence, and in this particular problem that's going to be 26. Alright, n again stands for the number of the term I'm looking for. So notice how n in my little subscript became 25 because I'm looking for the 25th term. So since this n became 25, this n is going to follow suit, and it's going to become 25. D stands for the common difference. We were doing that earlier. Just think about putting these two together in pairs, and always subtract. Take the second one in the pair and subtract the one in front of it, and you get negative 13. So negative 13 becomes my common difference. Okay, so this formula is going to take me directly to the 25th term in this list. Okay, and basically I'm going to use my calculator, remembering the order of operations, of course. So I'm going to multiply 24 times negative 13. So let me get back to my calculator and you can use yours. 24 times 13, that's negative 312. And now I'm going to add these two together. Actually, obviously they're going to be subtracted. So 26 minus 312, negative 286 is the 25th term in this sequence. So if we kept on running this out, following this same pattern, subtract, or you can think of it as adding negative 13 or subtracting 13, just keep on going. When you get to the 25th term in the sequence, it should be that number. So the explicit formula is great when we're looking for a particular term in a sequence that's way far down the line. The recursive formula it's okay, but for this particular case it's not very okay because it says this. To find a particular term, and we're looking for the 25th term. You know what this means? Well, it means if my subscript n is 25, then what would you get if you subtract 1 from 25? Obviously you get 24. Alright, and we've already found out that the common difference is negative 13. The recursive formula says this, okay, I will be able to give you the 25th term if you plug in the one before it and then add negative 13. Well, we don't have the 24th term. That's the limitation behind the recursive formula. In order to find a term, you have to know either the preceding term, which is the case here, or you could be able to find it if you knew the following term. But in the absence of either the preceding or the following term, it's very, very difficult. Because what I would have to do is kind of work my way up. For example, I know the first 4 terms, I know the 4th term, so I could find the 5th one. I could find the 5th one by using the 4th one and then adding the common difference. So the 5th term is negative 26. And then I could use that to help me find the 6th one, which would help me find the 7th one, and you get the picture. That would be a very, very cumbersome process to get all the way down to the 25th term. So in cases like this, I want you to be aware of this recursive formula, but when you're asked to find a particular term that's down the line, the explicit, you can think of the word direct, is a much better formula to use. And this is the one that I want you to show on these problems, 12 through 20. I want you to actually show it because that's hopefully going to help you memorize it and be able to use it when it comes time for quizzes and tests. So just to reiterate, when you do these problems 12 through 20 even, you need to show me the use of this explicit formula, this explicit arithmetic formula that we use to find a particular term in the series. I want you to be familiar with this. I want you to see the recursive formula. I want you to know what it's all about. The bottom line of it is that in order to find a term, this nth term, you have to know the previous term. So to find, for example, the 16th term, n would be 16, I would need to know what the 15th term is. 16 minus 1 means 15. And then I would take that 15th term and then add the common difference to get the 16th term. So not the best way in order to find a particular term in a sequence, especially when it's way down the line, far away from our last known term. So use the explicit formula, and we're going to practice it again on this example. All right, this says to find the 32nd term of this arithmetic sequence, okay, given here at the top. So once again, to use the recursive formula that I showed you on the previous slide, in order to find the 32nd term, I would need to know the 31st. I don't know the 31st. I'm only given up to term number 4. So think of this. To use the recursive formula, I would use the 4th term to get the 5th. I'd use the 5th term to get the 6th, and on and on and on. That's going to be very time consuming. Well, the explicit formula is very direct. I can find any term I want, any nth term, by using the first term, which we know, times the nth term minus 1 times the common difference. All right, and I just repeated that same formula that, oh, I forgot my plus sign here, sorry about that. All right, just repeated the same formula that I showed you on the previous slide. So this is the formula that we're going to use to find this 32nd term. So in this case, n is 32. I'm finding the 32nd term. A sub 1 refers to the first term, plus n is the term number I'm looking for. So once again, it's 32 minus 1. D stands for the common difference. So go back to what we were doing earlier and just pair these first two up and do the second one minus the first one, and you get 0.4. All right, so D, the common difference, is 0.4. Okay, so let's find the 32nd term. 0.1 plus, this is going to be 31 times 0.4. And let's just go ahead and do in our calculator 31 times 0.4. That's 12.4. And then we add plus 0.1. And we get 12.5. So the 32nd term is 12.5. Okay, so I hope that gives you some help on problems 12 through 20 even. Okay, let's help you out with some more problems. Like this is what you're going to do on 22 to 30 even. The directions basically tell you to find the missing term of between two terms of an arithmetic sequence. And this is pretty easy. It won't take you very long. If I want to find the term that's missing between, for example, 8 and 20, and I'm told that it's an arithmetic sequence, then I use what is known as arithmetic mean. Okay, and here is arithmetic mean. I just take the two terms on either side of the missing term, I add those two terms together, and then I just basically find the average and divide by 2. All right, so 28 divided by 2 is 14. So the missing term in this case is 14. So I want you to be familiar with arithmetic mean. Just add the two terms on either side of the missing term, and you always divide by 2. You're basically finding the average of those two terms. All right. This is another block of problems where you're asked to find arithmetic mean, but it looks a little different. For some people, this causes a little bit of confusion. You're looking for the arithmetic mean a sub n. So just think of a sub n. These are given in your problem. You can see that the notation is basically telling you this. A sub n is between these two terms. So this would be a sub n minus 1, which means the term to the left. And this would be a sub n plus 1, which means the term to the right. So once again, I think I used this example earlier. If, for example, this represented the 6th term, then over here, by saying a sub 6 minus 1 is another way of saying the 5th term. And over here, a sub n plus 1 is another way of saying the 7th term. So don't want you to get too confused about this notation. This is just another way of saying these are the two terms on either side of the missing term. So they could have just as easily expressed it just like this. What is this missing term? So we're going to take those two terms on either side, add them together, divide by 2, and we get our missing term is 4. All right, easy enough. Let's try one more of those. Same block of problems, but this time we're using all variables. All right, so once again, we're told that the term on the left of the missing term is the variable r. The term on the right of the missing term is the variable s, and we're supposed to find the one right in between. Well, the arithmetic mean says to take these two terms, add them together, r plus s, that's an s, and then you just divide by 2. And literally, since we're dealing with variables and we can't combine unlike terms, that is my answer. So the arithmetic mean of these two terms would be r plus s divided by 2. And that's it. Okay? Now, 64 to 70 even, you're still finding arithmetic mean, but in this case, you've got more terms. You're having to find 2 missing terms instead of just 1. All right. So, for example, I don't think they give you the -10. I think it's written like this. Yeah. Sorry about that. Okay. So this would be the way the problem is given to you in the book, and you got to find 3 missing terms. Well, to find the 3 missing terms, start with the one in the very center. And I gave it away. I showed you that it was -10, but here's how I got -10. Okay, well, think about arithmetic mean. The one in the very center will be the average of these 2 that we see on the end. So I'm just going to do 2 plus -22. I'm finding the arithmetic mean of these 2 on the outside, and that will give me the one in the very middle. So add those 2 together and divide by 2, and of course you can see that's -20 divided by 2, which is -10. Okay, so now finding the one in the middle helps me find these 2 missing terms. So to find this one, I'm going to use the arithmetic mean of 2 and -10. Okay, so just do 2 plus -10 divided by 2. And 2 plus -10, of course, is -8 divided by 2, which is -4. Okay, and I'm going to do a very similar thing over here. To find this missing term, I'm going to use the arithmetic mean of -10 and -22. Okay, so just add those 2 together, divide by 2. -32 divided by 2 is -16. All right, so that should be your answer for this particular problem. Okay, let me see. Do I have another one? No, I don't. That's my last example, so hopefully that made sense. But if not, you're free to send me an email or come see me in academic support, and I can guide you. But I think that should help you on these problems. So work hard on those, and we'll check them out later.